Our learning target for today is I can explain fraction equivalence using tape diagram and the number line and relate it to multiplication and division. So what we've been doing in math is we've been using the tape diagram to show equivalency. Today we're going to add the number line to help us see fractions that are equivalent. I'm going to start by drawing a tape diagram that represents 1/2. Just like we've been doing. Now, we know when we want to decompose a fraction, we use multiplication. So if I wanted to say 1/2, and I wanted to find it in fourths, I can multiply it by 2. And if I multiply the numerator by 2, I'm going to multiply the denominator by 2. And that will be equal to 2/4. So I can decompose it so that I have 4 equal parts. I can also decompose it into eighths. So I can find the equivalence of 1/2 and 2/4 and find it in eighths. I know that if I multiply 4 by 2, I will get 8, so I must multiply 2, our numerator, by 2 as well, and that equals 4/8. And I can show that with my tape diagram by decomposing and partitioning as evenly as possible. So I now have 4 equal parts that are shaded in, 4 equal parts that are not shaded in, still equal to 1/2. I haven't changed anything. I still have the same amount that is shaded in. And I can do the exact same thing with the number line. So I'm going to draw my number line, draw my arrows to show that it is always able to continue and still go. Start with 1 whole and 0. I know that I'm going to add my benchmark number of 1/2. So my whole number here would be 2/2, and my 0 would be 0/2. These are my benchmark numbers. I can always start by placing my 0 and my whole and finding my whole fraction and my fraction with a numerator of 0 and then the halfway mark. And I can add for equivalent fractions. 2/4 is the same as 1/2 and 4/8 is the same as 1/2. And that allows me to plug in the rest of those fractions. So I see 2/4 is here. I can add a tick mark as I partition it evenly to place 1/4. And I can do the same here to place 3/4. And I'm partitioning it evenly just like I did with the tape diagram. The number line shows smaller and bigger units of parts with the tick marks, just like the tape diagram does that when we decompose it using those dotted lines. So we're going to do one more together and then I'll have you try one on your own. I'm going to draw a number line that is divided into thirds. So my tick marks are going to start with 0/3, which is equal to 0, and 3/3, which is equal to 1. And now I can place it in. I know I'm going to have 1/3 and 2/3, so I'm going to try to partition as evenly as possible. I'm going to start with the fraction 1/3. And I'm going to think to myself, how can I find 1/3 equal in 12ths? How can I find the fraction that is the equivalent of 1/3 in 12ths? Well, I know that 3 multiplied by 4 equals 12. And knowing that, I can say to myself, well, if I multiply the denominator by 4, I must do the same with the numerator, meaning 1 multiplied by 4 is 4, so 1/3 must be equal to 4/12. And I'm going to use my tick marks to show equivalency. So to show this on the number line, so I know I can start in the middle. 6 is half of 12, so I can place 6/12 right here. 4/12 is the same as 1/3, and I can fit some tick marks. I know I'm going to have 0/12 under 0/3. And I'm going to need 1/12, 2/12, 3/12. And I fit 3 tick marks in between my 0/3 and 1/3. So I've broken it apart. It's the same jump from 0/3 to 1/3 as it is from 0/12 to 4/12. It's the same space. It's just broken up into smaller units. You're going to try the next fraction that I show. It'll be on the next slide. You're going to try it on your own and then check in with a friend.